After a decade of using ORMs, I've kind of rediscovered ADO.NET. Raw ADO.NET is faster than ORMs, intuitive, and you can actually build reusable components for common queries with the use of interfaces. In my most recent project, we used Entity Framework for all of our writes, but when it came to queries, I told my team I really don't care how they get the data. The result, a lot of ADO.NET code and a very fast API. In this video, I'm going to take 3 very common operations which you can build into small focused components. So let's go and take a look at a demo. The first one I want to show you is this class which I've called row counter, and its abstraction is pretty simple. It's just got one method, count rows, which takes a table name and returns an int, and the int obviously being the number of rows in that table. So in that first line there in the count rows method, you can see how we're using this thing called a DB resolver to get a connection, get an open connection. So I'll just talk through that first. If we go to this IDB resolver abstraction, you can see it's just got one mission in life, to return that SQL DB connection manager. And if we go and take a look at that, it's got one mission in life in itself, just to return an open connection, that being an SQL connection. And so these are all small pieces with very defined pieces of functionality. And you can see here in this get open connection method, it's relying on ADO.NET connection pooling. And so it's very efficient. You don't need to pass around and keep a connection open or anything like that. You can just go to this method and it will go to the connection pool. And so long as you're using the same connection string, you'll get a fresh connection from the connection pool, which is a very efficient way of doing things. Okay, so if we go back to this row counter, we use the DB resolver to get the connection manager to get an open connection. We then create a command using that connection, and then we pass the relevant SQL to that command and execute, casting the result to an int. There is a SQL injection issue in this method, and I'm going to come back and talk about that at the end. Let's take a look at our main method now. The first thing I've done is created a configuration object using the configuration builder. I'm just using the in-memory collection there because I didn't feel the need to create an app settings file for this demo. And all it's got is a connection string. As you can see on line 25, that gets hooked up by the service collection and it gets injected into the SQL DB connection manager. I've created a convenience extension method here, which hooks up the rest of the services and abstractions in the service collection. Now it's just a matter of resolving the row counter. And then once that's resolved, we pass in the table that we're interested in to the count rows method. And then that gives us our cities count. And if we run that, we can see that the cities table has a row count of 37,940 rows. Next up is another pretty common feature, and that's to retrieve a common list to populate a drop-down list. And I've got a method here called getSimpleList, which does just that. You pass in a query, some optional parameters, and there's a null check there. So the thing that we're returning is this iSimpleList item, and I've commented out that selected property, but the main 2 properties that you'd be interested in are an ID and a name. Quick word on the with null check parameter. Your record set may well return null values. You'd be best placed to know whether that's a possibility. So let's take a look at the implementation of that method. It looks pretty busy, and without the with null check, it would actually be pretty small. But we take our query and we run that query using that execute command query extension method, which you'll be able to see in the GitHub repo. And the meat and potatoes of this method is actually down at line 54. So when we get that data reader, we create that list of simple list objects. Now, we do have that with null check there, and that just checks whether those columns have nulls or not, and basically leaves out ones which do contain null values. Otherwise, this is the main part of the method, and it's repeated there if the null check is sent in and is set to false. So we get a concrete implementation of the list retriever, and then we pass into that the query that we want to run, and then we can iterate through, and you can see there that's brought back a whole lot of values. So we could actually use the second parameter to introduce a filter, and you see here I'm filtering on ZU, and that just brings back those. The final one that we want to look at is this item deleter, which just has one method, delete, and you pass in the table and a tuple which represents the key. So the key name being the primary key and the actual value for that key. So let's go and take a look at the implementation of that. It's actually a really simple method. We are just getting the connection using that reusable way of getting the connection that we have been doing. And we build up a query which we have a parameterized parameter in the filtering. Note there's still a SQL injection issue with that table variable, and as I said, I'm going to talk about that at the end of the video. Otherwise, this may, if your query is deleting more than one item, then you may want to tweak that last one, but I'm assuming that it's only going to delete one row. So now let's go and take a look at how we can do that. I've got this query here which is just getting back the last one in that cities table, and we're going to delete that. So we'll get a concrete implementation of the item deleter using the dependency injection. We pass into that the table that we want to delete it from and our abstraction for the keys. So that's the city ID and that value of 38185, and let's run that. And we'll now go back to the database, run that, and you can see it's deleted that last row. So let's finally talk about how we can eliminate the risks of a SQL injection attack. Now, it's kind of a unique situation here because we've got a token replacement happening on a table which is following a from keyword in the query. So it's not something that we can replace with a SQL parameter and parameterize it. So a legitimate table that might be passed in could be something like cities, and that would be fine. But if it's a text box in the user interface and the user types something like drop database, I can't remember the name of the database, worldwide importers or something, and obviously we don't want our database being dropped, and it shouldn't have. The user shouldn't have permissions to do that anyway, but if they do, we should guard against this here at this point. So to address this, we're going to use a whitelist. Now the whitelist could be all of the tables in the database or just some of the tables in the database. And it's pretty easy to knock that up reasonably quickly. So I'm going to create a new class called guard. And in that class, I'm going to return a static read-only iset, which is going to have the strings being the table names. Now, take a good look at the next query that I'm about to show you. Pause the video if you will, and note that I've got it in text mode there, results to text, and you just grab that, copy, put that in the clipboard, and bring it back here and paste it. We can now go back to the calling code, and all we need to do is add a guard like this. So if it's not in the whitelist, return 0, or you could throw an exception if you like, whatever way you want to handle it. And now we're back at the main method calling the count rows. We need a table. So let's just go back and pick a table and we'll test this out. So application countries is as good as any. We'll put that in there, clean it up. Let's run that, and you can see we've got 190 in that particular table. Now let's try and do the devious thing, and let's try and drop the database. In order to do that, I need to get the database name, so we'll just grab that from the properties. Copy, paste that there, and we should get 0 for the row count when we run this. So let's run that, and 0. So you can see just by adding a simple whitelist like that, it completely mitigates the risk of a SQL injection attack.